Hey everybody, it's Jason Blaha here, and today I thought I would kind of answer a question that came up. I had a very regular poster ask me, and obviously this will be up in a couple weeks after he asked it. In one of my other videos, he said, why aren't exercise science studies held to the same accountability as of peer review as other sciences are? And why does that make it kind of a joke? And it's a practicality issue, right? In order to do good science, you need money. Okay? And let's be honest, we already know how to get people muscle mass. We really do. There's no one is interested in spending $20 million funding a study. There's very limited grant dollars. And beyond a very, very tiny number of people, there's no interest in maximizing muscle mass. The health benefits that even medical doctors would advise for gaining muscle are easy to obtain. You could literally just go do starting strength or strong lifts, and that's it. You get all the health benefits you would ever need from just a health perspective. Cancer reduction, diabetes, cardiovascular risk, sarcopenia, all that stuff. So why do we need further studies? It's already there. There's already personal trainers. There's coaches with tons of experience you can hire. And quite frankly, we already know how to get people very jacked. There's no interest. No one has any financial interest or benefit in funding that type of research. They just don't. So accordingly, the grant dollars are very, very low. And that makes it problematic from a science perspective. I mean, we can claim all we want. Well, we've got tons of scientific evidence for these different modalities for training. But do we really? Because it's not good evidence. And that's kind of the point I made. It's 19 people, 20 people in a non-double-blind study. Okay, that would be considered horrific. That would not be considered good evidence for any other field of science. But it is only held to a lower standard because there literally is no research that is good enough. There's just not enough. What do we mean? Like, what would be good research? Okay, an idea to put in perspective. If we wanted to really study hypertrophy, what would we be doing? Well, we would take groups of people and we would do a study comparing two variables with 500 to 1,000 people. It would probably need to be 5 or 6 months long to really get a large enough distinction in muscle growth. Plus, since novices gain muscle so easy and they start from different varied points, it's very hard to use them for muscle growth studies. Why? Because they're not all starting kind of from the same point, untrained. Look at the average person walking around who doesn't lift. Notice that the amount of muscle they have and strength varies enormously. So some of them are starting at a much higher starting place than others. It's kind of problematic. There's a lot. It's very difficult to get them into groups that we can use. Plus, novices gain muscle pretty quick. It's not that useful of data. We already know how to get gains in them fast. So if we really wanted to make it great, what would we have to do? We'd need experienced lifters. Where are you going to find 1,000 experienced lifters willing to do a study? You're not. And keep in mind the funding we're talking about, right? So if you use novices, we really would need 1,000 people. And we would need to go through and make sure that we really had an even distribution of starting points, meaning a very even distribution in things like height, weight, gender, ethnicity, all of it. We'd have to ensure an even distribution of the starting points. In other words, you can't have one side stacked with more 6'3" guys who are 200 pounds starting out. You can't have one group have 3 times as many of those as another. So you really do need a very even distribution and something like 500 people in each variable group. Okay, that's what you have to have. You need 1,000 people. All right. Then you need it all double blinded with double checks. In other words, the researchers who were conducting say the MRIs to look at the hypertrophy can't know what groups they're looking at, because that's been noted that can create bias, because there is some interpretation of their readings. Okay, that has been noted by researchers in this. It's not a straightforward, hey, a computer tells you. No, they're interpreting a little bit of stuff there. Their personal biases can impact it. Okay. Now, for anything else we do in the world, what do? Everything is double checked. Right? I've worked in industry. Do you know that every single measurement is checked by 2 different human beings? On any important piece of industrial equipment, every bolt that's torqued, every measurement that is taken with a micrometer is all checked by 2 separate people behind each other. So for this to actually be valid, like a good thing against bias, it would need to be double blind. And you would probably want 2 separate researchers to measure each person each time you go through the testing of these 1,000 people over the course of the study, because you'd probably want to do the testing at regular intervals. All right. I think people are starting to get an idea of the enormity, how difficult it would be to measure things like muscle growth in a really good study that other fields of science would say, yes, this is correctly done. Therefore, the problem is we draw way too large conclusions from the data that we have. Now, can we still find some useful trends in it? Yes. But when those trends conflict with what we see in the real world, there's a problem. Because those of us who coach people, we know how the body responds. We observe what athletes and lifters and bodybuilders have done for decades. We have an idea of what to expect. When this data conflicts with the real world observations, because this is an applied science, we have a major problem, don't we? Okay? This is a problem. Now, what I'm saying with a lot of this is that we can't allow this to be our primary source of information, right? We have way too many influencers who they base everything off of this, and then this is gospel, right? And many of them are small and weak who are applying this data to themselves. Again, this is a problem because they build large followings. But then it's, well, you're arguing with science. No, you don't have sufficient scientific data to make these sweeping statements. That's the issue. Particularly if they do not match the observations of what we actually see. All right, and I do know people who, based upon that, say that it's all useless. I think we can find some decent trends. I do have friends who say it's completely useless because of that. You can't draw anything meaningful. I don't necessarily agree with that, but I think that we have to tread very, very lightly with it and put that in context when we are objectively looking at this stuff. All right, guys, but that's really all I have to say on that today. I hope it's been informative, and I'll talk to you guys next time.